Week 4 homework was starting out with number 32. Number 32 says, give the complete IUPAC name for the following. So let's look at this first one. We have 1, 2, 3, 4 carbons all in a row. So that's butane, or bute something. And we have an alcohol on the OH group, which is an alcohol group on the second. So it's OL for butanol. Now, how do you distinguish between being on the second versus on the first? So you would put 2-butanol, which means that the OH is on the second. So this is 2-butanol. B, we have 1, 2, 3, 4, 5, and that's the longest carbon chain regardless of how we do it. We have an alcohol group on the second carbon. We have an iodine group on the second carbon. And then we have 2 methyl groups on the third carbon. So it would be, let's see, 2-iodo, 3,3-di-methyl, that's the 2 methyl groups, 2-pentanol. Going back, we have 5 is the longest, so that's pentane. It's an alcohol, so it's pentanol. The 2 tells you that the alcohol is on the 2 carbon. This 2 tells you that iodine is on the 2 carbon. And then 3,3 tells you that both methyl groups are on the same third carbon. So it's 2-iodo, 3,3-dimethyl, 2-pentanol. The last one, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's a 6. And again, we have a hydroxide or a alcohol group here. And we're going to go this way because regardless of which way we go, well, we're going to go this way because that includes the alcohol group, and it's the it's the longest carbon chain without lifting your thing that includes your functional group. So it's 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6. So it's going to be hexanol. So 2-hexanol. Okay, now let's go back and take a look at, if this is the 2 carbon, the 3 carbon has an ethyl group and a chlorine. So it's going to be 3-chloro, 3-ethyl, 2-hexanol. 3-chloro, 3-ethyl, 2-hexanol. Now if we went this way, we would get a 6-carbon chain, but it would not include the functional group, and you need the carbon chain that includes the functional group. So that's number 32. Number 33 here, it says give the IUPAC name and common name for these 3. These are all ethers. So the IUPAC name is that oxy whatever, okay? So for example, this is ethoxy butane, okay? So you have 4, 1, 2, 3, 4, and you have ethyl group on the other side, so that's ethoxy butane. So it's ethoxy butane. But it also could be called ethyl butyl ether. Ethyl butyl ether. This is ethoxy propane, ethoxy propane or ethyl propyl ether. Now, actually, back when I was in high school, we just used these names. We didn't use these names. This is methoxy propane, methoxy propane, or methyl propyl ether. So that's number 32. The next one we have to do is 36. It says draw the condensed formula for each of the following. Dipropyl ether. Okay, 36. Dipropyl, so you have 1, 2, 3, CH3, CH2, CH2O. Dipropyl would be CH2, CH2, CH3. Dipropyl ether. 2,2-dimethyl 3-hexanol. First of all, let's draw the hexanol. CH3, C, CH, C, I'll get back to why I did that, CH, CH3. So there's 1, 2, 3, 4, 5, 6. Okay. Now we're going to put 2 methyl groups on the second carbon, which is why I didn't put any H's here. There's a methyl group here and a methyl group here. And we're going to put a OH on the third carbon, which is why I left 1 hydrogen out, because you have to have a bond for the hydroxy. So this is 2,2-dimethyl 3-hexanol. Lastly, 2-methoxybutane. 2-methoxybutane. Now, what that will tell you is you have butane, 1, 2, 3, 4, CH3, it's not drawing for me here, CH, CH2, CH3, no, not sure, there we go. Now, by saying 2, it means that it's attached to the second carbon here, which is why I left the hydrogen out. So it's 2-ethoxy, so that means we have CH2, CH3 down here. So 2-ethoxy butane. So that's number 36. Now we go from number 36, 42, 50, and 52. Okay, let's go to 42 first. Predict the products of each of the following. And when it says R, it means it's a reducing reaction, which means you're going to add a hydrogen here. In the other, or you're going to lose an oxygen is the better way to think about it, or add a hydrogen. And so for this first one, for example, if you take CH3CO, if you add a hydrogen to this, you end up with CH3CH2OH. You break this double bond, you're adding a hydrogen and a hydrogen. The next one would be CH3COCH3. You're going to change that to CH3CH3OH. Now you can actually take that another step and take this oxygen out and make it into just with no O. But if you do it just once, you get this. So CH3COOH would go to CH3COH. Now this could be taken another step to CH3CH3. This could be taken to another step to CH3CH2CH3. This could be taken to 2 more steps. The first would be CH3COH, H2, and then CH3CH3. And each so one reduction changes it this much, 2 reductions do go to this step, and ultimately 3 reductions in this bottom one go to that. 50. So it says, write the complete balanced equation for each of the following. One condensed and one using Lewis structure. I'll let you play around with the Lewis structures. I like just looking at the condensed formula. Ethanol plus propionic acid. So ethanol is CH3, CH2OH, plus propionic acid is CH3, CH2, C double bond O, OH. Now this is an acid plus a base, so it's going to give you an ester, which is the salt, an ester plus water. And so that is going to be, you lose this hydrogen and this hydroxide. So you end up with CH3, CH2, C, whoops, not sure why I did that, C, and this oxygen is going to go down like this, and then this oxygen is going to snap on like that, and then you finish it out, CH2, CH3, just like that, okay? So it's ethyl propionate. You start out with ethanol plus propionic acid, and you end up with ethyl propionate plus water. The second one is benzoic acid plus sodium hydroxide. So you start out with drawing benzene here, and benzoic acid is, you put a carbon out here. You see, it gives you a carbon here. You put a carbon out here, and then double bond O and OH, and you add to that sodium hydroxide. This is going to react with this, and you're going to end up with benzene, remember C, double bond O, O, sodium, sodium benzoate. This is called sodium benzoate, and water. And then the last one I think is 52. And 52 says the following. Yields in organic reactions are sometimes low. Calculate the percent yield 13 grams of ethyl acetate from 10 grams of ethanoic acid. Okay, so ethyl acetate, so you start out with ethanoic acid, and in order to get ethyl acetate, you have to add ethyl alcohol to that, CH3, CH2OH. These two combine to give you ethyl acetate, which looks like this. Plus water. Okay, and it's saying that if we start out, we get 13 grams of this, starting with 10 grams of this. Let me make sure I got those numbers right. Yes. Okay, if we look at this, we got 12 and 12 is 24, and 3 and 1's 4, and 2 oxygens is 32, so the molecular weight here is 0.60. So we have 10 over 60, or 0.167 moles of this. We should get 0.167 moles of this. But we only get 13 grams, which I have a sneaky suspicion that that's not the same. So 0.167 moles. And we have 1, 2, 3, 4, so that's 48. We have 3, 4, did I get that right? 1, actually there's no hydrogen there, sorry. So, well, wait a minute. Yes, there is. My bad. 3, 4, 5, 6, 9. And then oxygen, 2 oxygens, so that's 32. So now we have 989. So there's 89 grams per mole. So we should have 14.9 grams. So the percent yield here is 13 grams divided by 14.9 times 100. 87.5%. Now that doesn't sound like bad yield to me. I'm not quite sure, why they think that's a bad yield unless I did something wrong over here. If I did, I don't see it. So if you guys find a mistake I made there, you can let me know by email.